Mecca. I'm surprised Ron didn't want to come here. I think maybe he had enough of you like yesterday.
Wouldn't blame him.
I would direct you back to page 4 and we've come further south. So where have we come in our stratigraphy of the Sydney Basin? Down. Down, down.
Prices are down.
Prices are down. I was trying to think of the right word. So we're in the Wasp Head Formation, which you can see on here underlies the Pebbly Beach Formation. And you can see there's a squiggly line at the bottom of the Wasp Head Formation. What does the squiggly line mean? There it is. Okay, so that's the unconformity. Underlying that, you can see the units are denoted as the Wagga beds. Okay. Now, if you go to the map on page 25, you can see the same situation there in plan. So as we've been coming south, because the rocks are sort of dipping, I guess east-northeast is a good dip direction to call that. Notice that the dip angles have actually increased slightly over what we saw yesterday. If you look at the map, up at Pebbly Beach, the dips are around 2 to 3 degrees. Here they've crept up 5, 8, a little bit steeper, and you can actually see that. If you look over there, you can see the rocks dipping off to the east at a comparatively steep angle to what we saw yesterday. So this unconformity is actually exposed at Dark Beach as well. Now we haven't got time to go there. If you ever come back here, it is quite spectacularly exposed there. You don't see the basement in the cliff section, but you do see it on the platform at the bottom of the cliff. The unconformity is actually right at the bottom of the cliff. But it's very spectacularly exposed here. So these are the Wagga beds sitting underneath. One of your tasks is to draw the surface. So you're asked, I'll go back a page. We'll have a look at the Wagga bed, the rock types in a moment. So you're asked to describe the rock types above and below the unconformity. Question 2, you're asked to draw the contact. Now, don't just draw a line. Indicate what the rocks look like below, what's their orientation. You've got some blank pages somewhere in here. You should have extra paper with you anyway. Some of you have. There's a blank page before page 27 you could probably use. Okay, so draw that. Remember, a diagram for this sort of thing is intended to get across. It's not meant to be a work of art, it's meant to get across the point of what it looks like. What are the differences between, in the structure at least, between the rock types above and below? You can write in words for question 1 there what the rock types are, and we'll tackle that in a moment. But your sketch is meant to show what you see here.
So what that means is that there's going to be some main structures that will be obvious on your sketches, and there will be some details that pertain to the different rock types that we have. But this detail must be informative about the rock type. What are the detailed characteristics of the rock above the conformity and underneath? So don't make it too simple. It's not just one horizontal line. You need to give some details that show the rock type above and another detail, a very different detail underneath.
Okay, thanks for that. Notice that there's probably not a lot of variation in the rock types underneath, but there's a stark contrast between those and the ones above, and you do have variation. As you go up the stratigraphy there, you'll see that there are layers of quite contrasting rock types. Now you can include those in your sketch. Okay, I'll come back to what they are in a moment. Now it says, there's a few hints up the top here. I'll come back to the thinking questions. It says up the top here, there's been a proposed environment of deposition of these rocks here, and it says sublittoral to littoral. What's littoral? Not littoral, littoral. Sorry?
Where light penetrates?
Yeah, it's basically translates as shallow marine. Okay, so that could be anything from shore face out to shelf. I'll come back to that because we need to have a think about whether that's realistic or not. Okay, and that's really what question 4 is about. Do you agree with the interpretation that this is a sublittoral environment? But I will come back to that one. So the first, I'll shut up in a sec and we'll get you to sketch it, and then we'll have a talk about a few things, like the environment of deposition of that stuff up there, because it's a bit contentious, to say the least. Okay, what rock types have we got underneath? And what's their orientation? Yeah, it's pretty vertical. What is it that's vertical?
Bedding.
Is it?
Need to go up
Can
and
anyone
over
see? Yeah, you won't see it from back there. So again, you need to do some more observing on this trip. Can you see bedding in this stuff? What's the planar feature that is there? Is it laminations? I mean, laminations is just the same thing as bedding on a finer scale. Is it lamination? Is it bedding? Is it something else?
If you see a true lamination, you should see a bedding. And the bedding surface has a compositional variation. So you should see different rock types on top of each other. That's bedding. Look if you find any bedding.
That's a good point. That's one of the biggest mistakes that students make in the field, is to mistake other planar features for bedding. And bedding, as David said, if it's true bedding, you should see compositional variation perpendicular to that surface. You'll go from finer grain rocks to coarser grain rocks, just like we were seeing yesterday.
Well, it's almost like the orientation of the grains of the rock
Yeah.
seem vertical. That's the best way I can describe it.
Can anyone see compositional variation in the underlying rocks? There's certainly a strong planar feature there. Yeah. What other planar features do you know that you learnt last year?
Just a sec, I got last year's book in here.
You're not allowed. No, you're not supposed to ask the audience. Phone a friend.
But this is my only friend.
I keep forgetting to get the. I need some tissues. I keep forgetting to bring the QI klaxon noise along with me on the phone. So. What other planar features do you know? You learnt them less than 6 months ago. Yeah. Well, foliation is just a generic term, but bedding's a foliation. So foliation is another way of saying planar feature. What other foliations do you know of? I know where you're heading. More specifically. That's the rock type. What's... Yay!
What is it?
Cleavage.
Cleavage.
That's one type.
That's one type, yes. There are others. I had the words schist and gneiss called at me over here. What's the foliation in the schist called?
I've heard it.
Like
A schistosity. Yeah, and in a gneiss it's a gneissosity. Okay? At lower grade rocks it's cleavage.
Well,
And there's several types
have
of
a
that.
look here. What's the difference between a cleavage and a schistosity or an gneiss? The difference is, can you see the minerals with your naked eyes? So look at the rock. You see a planar feature, for sure. But can you see the minerals that make out this planar feature? If you cannot see the minerals with your naked eyes, it's not a schistosity. It's too low grade. The grains are still very, very small. You can't see them with your naked eyes, and therefore we call that a cleavage, not a schistosity. Well, there are metamorphoses, but that's low enough grade. Very low.
Yeah, so can anyone see any individual mineral grains? And no one's seen any bedding? Okay, so we said if it's not bedding, it's probably some sort of tectonic foliation. And because we can't see mineral grains, then we call it a cleavage. Okay? What would you call the rock type? Low grade, strongly foliated. Yeah, slate. What's the other option? Phyllite. There's a bit of a fuzzy boundary between those. Yeah. I'm happy with slate. Are you happy with slate? No? Yeah. What other sorts of deformation features might you see in a low-grade metamorphic rock like this other than foliation? What's the other thing? Yeah, you might see lineation. Okay, now that's a little bit hard here. Where do you need to look to see a lineation?
Which one is it?
Yeah, on the foliation surface. And really you're not seeing the foliation surface here, you're seeing a surface perpendicular to foliation, which is why you can see the cleavage, okay? So we've got these things started out, I don't know whether it's described here, they're fairly fine grained, so you would imagine that the precursor, at low grade, the precursor or the protolith had to be fairly fine grained as well. So what sort of rock type might the protolith have been? Yeah, it might have been something like a mudstone. When we go down to the southern end of the beach, you'll see more of the Waggonga beds there, and you will see preserved bedding there. And you'll get a better idea of the variation that occurs in the Waggonga beds. Here it's pretty simple. We can't see bedding, quite a strong cleavage, we can't see individual mineral grains, so we can just call it a slate. So when you do your sketch, make sure you indicate. Those people with compasses, it probably wouldn't hurt to take a strike and dip at the cleavage here. We've probably got quite a few of you who need your compasses declination set.
Yeah.
So here, we want them to measure it here, David, as well as...
I don't really know if we need them to measure here.
I might just do a...
Practice.
Well, you'll be practicing down the southern end of the beach. I might just take a measurement and everyone can write it down.
Yeah. Because I think it's probably better at Myrtle Point to do that.
Yeah. Yeah, but it probably wouldn't hurt to record something like this when you come to a field spot like here, and it's relatively remote. It's a bit bad to say to get back to Newcastle and go, oh shit, I didn't measure the cleavage while I was there. Long way to come back.
Well, they need the orientation of the cliff anyway.
Yeah, they do. So what's the orientation of the cliff?
Northeast.
Pretty much east.
Yeah, northeast. Southwest.
I've got about 080 here. Maybe 070 at a pinch. Let's call it 075. So the cliff line is sort of east-northeast, west-southwest in terms of its orientation. You can see over there it bends around and kicks further to the southeast.
So what that means is that your sketches have to have northeast on one side, southwest on the other. The top of your sketch is up, bottom of the sketch is down. Sorry? Where's the